ln x, log x, log 10 for x, and log exponential for x. Do they the same? Hi, I'm Kadri. In this video, we are going to learn about logarithmic function. At the end of this lesson, you will be able to use the properties of ln x, natural logarithmic of x in the problem solving. Let's start with logarithm. Alright, for an exponential function y as a equal to x, y equal to a as a power of x, then we can have logarithmic base a for y equal to x. Okay, properly look at it. So y equal to x power by x, then x is equal to log base a for y. Alright, so taking x as the dependent variable, okay, this is as a dependent variable, and vice versa. So we can have log base a for x equal to y, in this case, so actually basically both are the same, right? So this is called the inverse function of y equal to x power by x. So this is the inverse function of this. Alright, so we call here this expression as log with base a of x. Okay, base a of x. So this base, because this a base can be any number, right? It can be any number. Alright, in case of a equal to exponent that we learned from the previous lesson, where exponent is equal to 2.7, right? So this is about 2.7 blah 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 blah. Okay, so this exponent, if a equal to that exponent, so we can have log e, so this is the base x, then we can write it in another notation as ln x. So ln x is the called natural logarithm. So L is logarithm and is natural. I don't know why it's natural is the right side, but this is the logarithmic and this is natural of x. So we can write this if the base is exponent. Okay, for that is for a, the base equal to exponent, but for the base of 10, okay, for example, y equal to log base 10 for x. So this log 10 is can be just be at log x. That means if we don't put base, it is automatically understood as base 10. So this is called common logarithm. Okay. So how this exponential graph and logarithmic graph looks like? Alright, so this is the graph for exponential power by x. So this is what we learned from the previous lesson. Its inverse is in this way. Alright, so I made correction. So I have to make a correction. So this is not y equal to power by x. So okay, this is y equal to logarithmic natural logarithm ln x. Okay, they are mirror to each other with a condition if the scale is the same, x and y, if they are the same scale. So we can see this is the mirror axis. So the exponential function and its logarithmic is mirror to each other. It is like a reflection. Alright, okay, let's go to the property of this natural logarithm of x. So first one is that exponential power by ln x equal to x. Okay, second, ln 1 equal to 0. Okay, so if we look into the graph, okay, sorry, this is also wrong. This is y equal to ln x. Okay, at if x equal to 1 here, so you see that this is 1, 0. Okay, and log exponential equal to 1. So this is the exponential 1. So this is the point. Okay. Then for the product of LAB equal to ln A plus ln B. Okay, for example, we have ln 3 times 2. Okay, so we can separate them into ln 3 plus ln 2. Okay, and then for the division, if we have ln 3 divided by 2, then we can separate them as ln 3 minus ln 2. Okay, then for here, logarithmic a power, for example, it takes 2 power by 3, then we can bring 3 in front, then we have 3 ln 2. Okay, so ln x will approach to infinity as x equal to infinity. So in this way, right? So the ln x will go to infinity, to the top, to the right. So it will go forever. That means it's a infinity number. But if we go x approaching 0 here, when x approaching 0, so we see that the value become negative infinity. It goes to infinity. Okay, it goes down, so negative infinity. Alright, so these are important property of ln x. Alright, for back to our initial teaser. So do they the same? Okay, so these are the same. This is the pair, and this also the same. So it is important for you to recognize how to calculate the common logarithm. This is common logarithm, and this is natural logarithm. Okay, so on your calculator, recognize these two buttons. So alright, so this is to calculate the natural logarithm, and this can be calculated for any logarithmic with any base. Okay, so this depends on your calculator. So recognize them so that you don't make mistake. Alright, so in the next lesson we will use the property of the ln to understand about growth and decay, exponential growth and exponential decay. Okay, bye. Thank you.